Let me take a screenshot of this and we'll go through each of these.
Okay, cool.
All right, back to math.
Good old math, right?
Good old math. So these are actually pretty easy. Okay.
Yeah, they're not that bad.
Whenever you're solving an equation for a variable, the secret is to isolate it. The last line you're going to have is v equals something.
Right.
Okay, so how do I get rid of the t?
Divide it.
Okay, so v equals d divided by t.
Cool.
Now, number b, a little bit more difficult.
You would multiply it, right?
Okay, so what's the next line?
Would it be TD is equal to V? Or V equals...
No, if I multiply both sides, I got to multiply both sides by the denominator, which is v.
Okay.
So it's going to be TV on the left equals D on the right. Right?
Okay.
Those two are the same.
Right.
All I've done is multiplied both sides by V.
Okay.
Now solve for V. What's V equal to?
And then we would divide by T.
Exactly.
Okay.
Same answer.
Yep.
Oddly enough. Okay, hold on. The third one.
Okay.
Remember, we're trying to isolate V. So we got to get rid of this 1/2. We got to get rid of the m, and we got to get rid of the squared.
Yeah.
Don't get rid of the squared first. That's always going to be your last step.
Okay.
So get rid of the 1/2 and the m. So what is v squared going to be equal to?
V squared is going to be equal to KE over 1/2 m.
Okay.
Cool.
Now hold on. It's not the way to write that.
Okay.
What can I do with that 1/2 that's in the denominator? How do you divide by a fraction?
Multiply by the reciprocal.
Okay. So that's really a 2. Right.
Yes, that'd be 2KE. V squared is equal to 2KE.
Right.
Okay.
Now, what did I have?
Now you square root both sides.
Yeah, now you take the square root of both sides, so v is equal to what?
So it'd be v is equal to square root of 2KE.
Well, first of all, whenever you solve an equation by taking the square root of both sides, what are the first words got to be out of your mouth? Whenever you solve an equation by taking the square root of both sides of the equation, which is what you're doing here, your answer always begins with the same 2 words.
Square root of?
Plus or minus.
Oh, plus or minus. Okay. I got you.
Everybody forgets that. But you will lose points if you forget. And then you're taking the square root of everything.
Right.
So what goes on the inside is 2KE divided by m. And that's my
okay. Cool.
Okay.
Okay.
Next one.
Yeah.
What's v squared? First of all, we'll do it step by step. The next line is going to be v squared equals what?
So it'd be v squared is equal to a divided by r.
No.
Right.
This is a mistake that you make repeatedly. And what the mistake is you're doing the same thing to both sides. If I divide the right side by r, I don't get rid of that r. I got to multiply. In other words, I always got to do the opposite. Right now, that r is dividing into v squared. So I got to multiply both sides by r. Okay. You always do the opposite. If I'm adding a number to one side, then I'm subtracting. If I'm multiplying by a number both sides, then I'm dividing. Okay. Always do the inverse. Now, what's v going to be equal to?
V is equal to plus or minus square root of AR.
Yeah.
Cool.
All right. guess up here on the right.
Oh, wow. Yeah, there's more.
Yeah,
I
V
didn't
is
see
in the
those.
denominator, right?
Uh-huh.
So what's the first thing we need to do?
Multiply by V.
Yeah, what's the next line?
Hold on. So it'd be TV is equal to 2 pi r.
Uh-huh.
And then we would divide by 2 on both sides, right?
Not by 2. Remember, we're solving for V.
Right.
So you got to get rid of
So
whatever
divide by
is
2.
attached to the V.
Yeah. So divide by T.
Right.
Since it's being multiplied.
So that's the answer. V equals 2 pi r over T.
Okay, cool.
Okay.
Yeah, these aren't bad.
Number F, what is V going to be equal to? And the way you pronounce that is lambda. That's the Greek letter lambda.
Oh, okay. So we multiply by Fanda, is it?
Lambda?
Land, okay.
Lambda?
Gotcha.
Yeah, it's from the Greek alphabet. So
Okay,
I
gotcha.
multiply both sides by lambda, I get lambda.
Oh, okay. That's kind of interesting. I never knew that existed.
It's Greek letters are pretty big in math, and I'm almost ashamed that I don't know more of them. I
Oh, it's
know
all right.
alpha, beta, epsilon, delta, omega. Some of those, pi is a Greek letter, but some of the Greek letters I don't know. Like
Right.
this one here, I'm not sure what that is. This is omega.
Yeah.
Delta, and lambda is just one of them.
Theta. I knew theta, yeah.
Okay, let's solve G. First thing I
Okay.
gotta do.
So for this one, we would divide by T on both sides.
Not yet.
Not yet?
Always do your subtraction and your addition first.
Okay.
So I want to get rid of that, right?
Right.
It's being added right now.
Uh-huh.
So let's subtract that from both sides.
Sure.
So the next line is going to be VT equals D minus 1/2 AT squared.
Okay. Yeah, that makes sense. And then we would divide by T on both sides.
Yeah, just divide both sides by T.
Yeah.
And there's your answer.
Cool.
Okay. So solving equations is always getting rid of whatever's being added or subtracted, and then get rid of everything else. Here you have V being multiplied. So the next thing to do is divide by T.
Yeah.
But always, you don't want to divide by T right off the get-go because that complicates the issue. If I divide by T, now I get that, but then I got to divide that term by T also.
Right.
And so it makes it a little bit harder.
Okay.
Okay.
Yeah, okay.
How about number 2? I want to make sure you can do this one. These fractions give you trouble.
A little bit.
Okay. So first of all, let me help. Let's rewrite it.
Yeah.
It won't give you trouble if it's not a fraction. That's the same thing as what you're looking at.
Yeah.
Now, what's the first step if I'm solving for T?
Multiply by A since it's being divided.
No. A is not a divisor. A is a multiplier. What's being divided? What's the divisor?
2.
Okay, so I want to multiply by 2.
Okay, so it'd be D2 is equal to AT squared. Okay. Or 2D. Yeah.
Now what?
Hold on. Then since it's being squared, we can square root both sides.
Not yet. You don't want to, that final step is reserved for when you get it down to T squared. I don't have it down to T squared. I got A times T squared. I got to get rid of the A first.
Divide by A.
Okay. In other words, the steps you do these are very important. Okay. You got to get rid of adding, subtracting, and then multiplying, dividing, and then square root. That's the process. Okay. You don't want to do them in any old order.
Okay.
So what's T equal to?
The square root of 2D over A.
Almost.
plus or minus.
Okay.
Yeah.
All right.
Okay.
We're solving for t.
Yeah.
So what's the next step?
Oh, it's in parentheses. So
More importantly, Dylan, t is in the denominator. You can't solve for t when it's in the denominator.
yeah, you're looking at b, right?
No, we're solving for t.
No, I know we're on 2b
yes,
though.
yes,
Okay.
we're on 2b. So,
Okay. No, you're fine.
so
You're good.
how do I get t into the numerator?
Multiply it.
By both sides by t.
Yeah. So
Yeah.
b.
Make sure you say that, because just saying multiply by it doesn't say anything.
Yeah.
Because you're not just multiplying it. You're multiplying both sides by t.
Okay.
Doing. And that's what you get. Now you're solving for t. Next step is trivial. In other words, I now have t in the numerator. And that's where I got to get it to before I can solve for it.
Okay.
I can't really solve for it when it stays in the denominator.
Okay.
So t is equal to
mv over f.
Okay. On C.
So 2 squared is equal to kr to the third. Okay.
Only one step.
Yeah, just you can't square root both sides.
Why can't you?
Because there's a cubed root on the right side, or a cubed.
I can still square root both sides.
You can't, even if there's a 3 there?
Sure.
Okay.
In other words, you can take the square root of r cubed. Now, that actually simplifies. In other words, r cubed is r squared times r. So I can pull an r out.
Oh, okay.
In other words, you always want to simplify radicals if you can.
Yeah.
So I'm going to pull an r out, and what's that leave inside?
That just leaves k to the third.
Oh, leaves kr.
Or kr. Just kr. Okay.
Now, let's talk about this.
Sure.
If I'm going to take the square root of r cubed, and that's what I'm talking about doing, well, that's the same thing as the square root of r squared times the square root of r, right?
Okay. Yep.
What's the square root of r squared?
Square root of r squared is just r.
Okay, so that thing becomes r root r. That's what I got over here, is r outside and one r still inside, because it was r cubed. If it had been r to the fourth, then I could have pulled out two r's, or an r squared, and I would have pulled them all out. But you pull out what you can pull out only. And what's left over is the square root of kr still. So this is the answer. Okay. Let's see. D?
So it's p equals w divided by t, so we would just multiply by w.
Not so w.
We're supposed to get t by itself, though, right?
We're trying to get t by itself, but it's in the denominator. You cannot work with it when it's in the denominator. First of all, if I were to do what you say, if I multiply both sides by w, this is what I end up with.
Yeah, it's not right.
Not helping at all. I'm not getting it.
Okay.
So the first step is to get t into the numerator.
Okay.
How do you do that?
Multiply it by both sides by t.
Okay. They're giving you a lot of problems that require you to do this step.
Yeah.
So when the variable that you're trying to solve for is in the denominator, know that the first thing you need to do is to get it into the numerator, if at all possible. And now the next step is always trivial. In other words, dividing by the coefficient of t. All right, let's look at 3a.
Okay. So it's G.
F.
So okay.
F's
so
already in the numerator.
Yep. So we could, well, to get F by itself, we could multiply GM on both sides.
Okay, good. That's MGM equals FR squared.
Yep.
Now what?
Divide by F. Well, no.
We're trying to solve for F. You want to get rid of everything that's with F.
Yeah.
So what's with F?
R squared.
How do I get rid of R squared?
Square root each side.
Nope.
No.
If I square root both sides, I'm not going to be left with F. I'm going to have the square root of F. And then I'm going to have a times R. That's not going to help. What? Just divide both sides by R squared.
Okay. Okay. Yeah.
You see? In other words, the goal is always isolate the variable you're trying to solve for. So anything that is with it has to be gotten rid of. And you don't get rid of R squared by taking the square root of it. You get R.
No, yeah.
I take the square root of it. But if I divide both sides by R squared, I do get rid of it. So this is the answer because those cancel. But it's okay. Let's just keep doing. I guess.
You can't. Can you have a square number in the denominator?
Well, yeah, we haven't had one of those yet.
No.
I guess we kind of maybe have it on the D.
I think we could just leave it like that. I mean,
well, you talking about this problem we just did?
Yeah.
No, there's no square root anymore. I got F equals M times GM divided by R squared. You can certainly put R squared in the denominator. And you can have a square root of R in the denominator.
Okay, yeah, that's what I was asking.
You prefer not to. You could multiply top and bottom by square root of R so that your square root of R is in the numerator, not the denominator. So there is some things you can do if you do have a square root of a variable in the denominator.
Okay.
B is quite easy. What's F equal to?
AM.
And C, what's F equal to?
F is equal to D over W.
Nope.
Wait, I haven't wrote it down yet. Hold on.
Do it step by step. Don't try to jump from the first line to the third line.
Yeah.
What's the first thing you have to do?
Get rid of the W.
Nope.
Right. Oh, this is
F is in the denominator. You got to get F into the numerator. How do I get F into the numerator?
Multiply. So it'd be FD is equal to W. And then we would divide by D on both sides.
Now, when you did it in one step, you got the reverse. You got D over W.
Yeah.
So don't do it in one step. Always do it in two steps. And remember, the very first thing you got to do is get that thing in the numerator.
Okay.
Now, this one's a little different. The variable I'm trying to solve for is in the denominator. So I eventually want to get it into the numerator, but all of this is under a radical sign too. So it's not so easy to get it into the numerator directly, immediately.
We have to square both sides first.
Yeah, if I square both sides, then I get D squared equals KQQ. Oh, they're so cute. Who would stick two Q's next to one another like that? Maybe that's a G. No? I don't know.
No, I don't think so.
But anyway, now what's the next step?
Okay, and then now we could, let's get F by itself.
What do you got to do first to get it by itself? You don't just have to get it by itself. If I end up with 1 over F, I have not solved for F.
No.
I got to end up with F in the numerator.
So you would multiply both sides by F.
Now what?
Let's see. Hold on.
Now you're trying to solve for f and isolate it, and it's already in the numerator, so all you got to do is get rid of the d squared.
Yeah. We could divide by d squared.
That's it.
Cool.
Notice that solves for f. Whereas if I were to try taking the square root of both sides, that just gets me so I can't see the forest from the trees anymore.
Right.
All right. Time we look.
That's a good.
8:27 here. Let's see. Is 4 the bottom one or? Oh no.
There's 4 more. They're like word problems.
We're just doing a half hour tonight?
Yeah. Mm-hmm.
Okay, let's do one more. We got time for one more problem.
Yeah, let's do one of the 4, like 5, 6, 7, or 8 down there.
Okay, yeah.
Because the graph is easy. I mean.
Please draw a time distance graph. Yeah, I think you can do this.
Yeah.
Time's always going to be the horizontal axis. Whenever you're graphing time with pretty much anything, time is going to be your horizontal axis.
Right.
All right. Let's look at this one here.
Okay.
Number 5.
Okay.
I'm sitting there staring at that R, and I'm saying, what variables are they talking about there? And that's not what it means. You know what R and R means?
Yep.
Rest and relaxation.
Yep, exactly.
That's what they mean by that. Okay. So if she drives at 30 miles an hour for 30 minutes, how far will she drive? Careful with your units. Whenever you're dealing with rate, time, and distance, what's the equation that is the master equation?
So if she drives, so it'd be
Start
30.
with the master equation. Forget the problem for a moment.
Yeah.
All we know about this is that it's a rate, distance, time problem.
Okay.
Okay? So I got to have the master equation.
Mm-hmm.
What is it?
Would it be 30 mph over 30 minutes?
Give me the master equation, not with numbers.
Master equation.
E equals RT, dirt.
Okay.
That's the way I remember it, dirt.
Okay.
Now, obviously, there's lots of manipulations of that. In other words, T is going to be equal to D over R. R is going to be equal to D over T. But the master equation is dirt. You won't ever forget it if you remember it like that.
Okay.
Okay. Now, they've given us 2 variables. They've given us the R, and they've given us the time. So distance should be relatively easy. Distance is, and they said be careful of your units.
Yeah.
That's miles per hour. Okay?
Okay.
And time is 30 minutes. That's 1/2 hour.
Yeah.
And I've got to do it in hours because I've got to cancel the hours. So the distance she travels is 15 miles.
That's easy. Yeah.
Okay? And I could have done it the following way. In other words, I've got D equals RT, B equals 30 miles per hour times 30 minutes. That doesn't give me an answer. Nothing cancels. But if I add the following factor, where you have 1 hour per 60 minutes, right? Now notice the minutes cancel, the hours cancel, and the 30 divided by 60 is 1/2. So it's 1/2 times 30. I still get 15 miles. Okay? It was just the way I did it the first time. I converted the 30 minutes to hours immediately without adding another conversion factor. Like I did the second time. Okay. But that's why they put that note in there, because it'd be really easy to make the mistake. Well, of course, if you multiply 30 times 30, you would get 900. And it's pretty easy to know that you're not going to go 900 miles if you drive at 30 miles per hour for 30 minutes.
I don't think that's how it works.
No, we wish.
Yeah. We wish. Yeah, that'd be nice.
Time machine, maybe. But,
yeah, exactly.
So when you're doing problems like this, when you get done with them, always ask yourself, am I in the ballpark? You know, had I not noticed that this is in minutes and this is in miles per hour, I would have gotten 900. Well, that's not a ballpark answer. That's way out of the ballpark. I know enough about driving a car for lengths of time to know you don't go 900 miles in 30 minutes going at 30 miles per hour. So this tells me, wow, I must have made a major mistake. Let's go back, see if we can figure out what it is. And what it was one was in hours and the other was in minutes. You got to make sure all your units are the same.
Okay. And then for number 6, would you set 70 miles equal to, how would you like,
all right,
would you do 40? Okay. If you have time. If you don't have time, no worries.
No, I do.
Okay. Okay.
So what's the master equation?
Dirt, so D equals RT.
What's the distance?
70 miles.
Her average rate is 45 miles per hour. Can divide both sides by miles. Multiply both sides by hours and divide both sides by 45. So I end up with 70 hours over 45. That's how long it will take her if she averages 45 miles an hour. And that makes sense too. You know that if you're going 45 miles an hour and you're going to go 45 miles, it's going to take you 1 hour. So if you're going to go 70 miles, it's going to take you more than 1 hour. It's going to take you almost 2 hours. And 70 divided by 45 is almost 2.
Yeah.
So this is definitely ballpark. But again, notice what I had to do with the units. In other words, the units have to work out. If they don't work out, you've done something wrong.
Right.
And I could take this hours. When I said multiply top and bottom by hours, you can do that. And that gets rid of the hours and puts it in the numerator. And then you end up with an answer that's in hours.
Okay.
Okay?
Cool.
But dirt solves these problems every time. They're going to give you 2 out of the 3 variables. Just plug them in. Make sure your units are all the same.
Okay.
Do the math.
Cool.
In this case, because the units were all the same, I really didn't need to worry about them. I could have just said 70 equals 45 times t, therefore t equals 70 divided by 45, which is the answer. But without the units, I don't know if that's hours, minutes. In other words, I happen to know it's hours because that's the only time frame in there. But I didn't need to convert anything else. It wasn't like this problem 5 where one was in miles per hour and the other was in 30 minutes. Then I got to change some stuff.
Yeah, for sure.
All right.
Cool.
7's pretty easy. There's the master equation, and they're giving you the acceleration and the mass. There's the mass, 5 kilograms. There's the acceleration, 2 meters per second squared. Fill them in, solve for F.
Okay.
Your units might seem a little strange to you, but it's as straightforward as that. There's really no difficulties there.
No.
And I'm sure 8's the same way. Now, there's your master equation. They're going to give you the speed of light, which is that. Square it. Multiply it by the mass. And that's the amount of energy
Perfect.
there is in 0.0045 kilograms.
Mm-hmm.
All right.
All right. Perfect.
Hey, Dylan. Well,
All right.
you have a good one. I'll talk to you next time.
Thank you. Sounds good. Thanks, Mr. Cowan.
All right. Bye-bye.
All right. Bye-bye.